Now, memory mapping and protection is very important because the operating system needs, because we have operating system here, we have user process here. So the operating system must be protected from the user. These two have to be protected. So from the user process, and user process must be protected from one another. So here we use a relocation register with a limit register for protection. What is this relocation register? It contains the smallest physical address, and the limit register which contains all the range of the logical address. What MMU does here, memory management unit, it maps the logical address dynamically, adding the value of the relocation register, which is simply the addition value, same for all. So this mapped address is sent to the memory now. So when the CPU scheduler selects a process for execution, any process, the dispatcher will load the relocation and the limit register, right? And since every address generated by CPUs checks against these registers, we can protect both the operating system and the programs from one another, or data from one another, from being modified accidentally by this running process. So this is what is done. The CPU generates some address, the base is added. Now if this CPU is greater than or equal to this base plus CPU address, if it is greater, then we go ahead, otherwise we trap an error. Then we add the limit also, and if it is less than this whole is less than the value which is coming, then we go to error, otherwise we address it to the memory. So the relocation register scheme provides very efficient way to allow operating system size to change dynamically. So there are transient operating system code also, that is operating system code that comes and goes as needed to save the memory space and overhead for unnecessary swapping.